Okay, then let's proceed. So we looked at how to rename a variable, and we said that you start with the new name, then followed by the old name, followed by the old name. But now we are going to look at how do you add labels? How do you add labels? How do you add labels to a variable? And you use the function attributes. Then the data frame, the variable, then you label, then you create the label here, HIV status. So when you execute this line, you'll see that we've created a new label, and when you look at our data frame here, our variable here, HIV, has a new label. So that's how you add a label. We're going to look at now part of descriptive statistics, and here we want to know percentage of HIV, of TB HIV patients. That is, those TB patients with HIV. So we come here and first of all, look at the levels that are there in our HIV, and we have declined, negative, not done, and positive. That means it's only negative and the positive, those patients with the negative result and positive results were tested, but declined and not done, they were not tested. Therefore, we come here and say that we select the variable HIV. Then we filter HIV only when it is negative or when it is positive. Then we do the count and we get the proportion. So when you execute this code here, when you execute it, see that there's a new object called HIV that we've just created. There's that new object called HIV. When you print the object or you view it, so when you print it, it gives you that HIV status is, those who are negative were 36,796, whereas those who are positive are 15,181, which represents 70.8% and 29.2% respectively. And here we can conclude that our positivity rate is 29.2%. What if you want to get the percentage of under 5 TB patients? What if you want to get percentage of under 5 TB patients and you realize our age group has not been categorized? Our age is not its numbers. This is our age variable here that we created from alphanumeric to this new age 2. So we need to create another variable for age group so that we have pediatrics and others. We have pediatric and the others. So first of all, we will select the new age. Then we will create a new variable called age group. Case, we use the function case underscore when. Then new age is less or equal to 5, then that's a pediatric. Else, it is others. So we use the function true, it is others. So if it's not, if it's greater than 5, then that is true, we refer to as others. Then we count and we get the proportion. So when you execute this line of codes, when you execute that line of code and you view the object that we've created as PIDs, we have others at 94.1%, 94.1%, while pediatric we have 5%, that is 0.05, which represent 5.9%. And that's how you calculate. What if we are interested to know what is the proportion of under 5 TB patients? What is the proportion of under 5 TB patients? Again, here now, we want to look at what is the proportion of under 5 TB HIV patients. We come here again, we create. Now here we'll say case when as the previous up to this point, but now we add the filter for HIV status. Remember, the previous one include both not tested and tested, but here we are only interested with TB HIV. So we create HIV is exactly equals to positive or HIV is exactly equals to negative. Then we get the age group, we filter by pediatrics, and then we count the HIV status. So when you execute these lines of codes, we've created a new object called TB HIV. So I'm going to explain stepwise. The first line, script 146, is for selecting data. The second script 147 is to select the variables of interest. The third is to create a variable called age group with the following conditions. That is, new age is less or equal to 5, that's a PID, else it is others. Then line 151 is to filter now to get only those who are tested for HIV, pediatrics who are tested for HIV. Then line 152 is to separate others from pediatric, so that we remain with only pediatric. Then 153 is to count out of those who are tested who are pediatric, how many of them were tested for HIV. Then the last one is to create a variable for proportion, which will give us the proportion. And when we view this line here, you see now we have, for pediatrics alone, those who are tested, 2,622 were negative, while 336 were positive. And this represents 11% of our pediatric patients who were tested were HIV positive. And it begs the question when it comes to PMTCT program, that is prevention of mother-to-child transmission, because these children, they were infected with HIV from their mothers, and therefore we need to share this data with the HIV program to see why is it that our babies are still getting infected, and yet we have a robust program of prevention of mother-to-child transmission, that is PMTCT, or you can refer to it as EMTCT. Thank you for watching, and remember to subscribe to our YouTube channel and also click the notification button. We're going to look at data visualization. This is pictorial representation of data. We refer to it data visualization. It can be charts, graphs, pie charts, box plot, and many other visualization that you can do in R. The first thing when it comes to visualization, you need to create objects in table format. Remember, our DF is not in table, it's a data frame, and we need to convert these variables to table. And that's why I'm creating an object called counts. So these counts, I'm saying store county, but it should be in a table format. So when I execute that, you'll see we have that. Then I want also to create a function for colors. I don't want to name colors yellow, red, black, what have you, no. I want just to create an object for colors, and here I'm creating what we call rainbow colors. I'll use it when it comes to visualization. So we've created. Then now our first graph, we want to create a bar plot. Create a bar plot, a bar graph. So here I'll use the function bar plot. Then my data for county, I've stored it in this table called counts. Then main is for the heading, the title. Main is for the title, and xlab is for the label for the x-axis, which we call counties, and then the ylab is for the label for the y-axis, that is number of TB patients. Then the color is the function that I created up there using the rainbow colors. So I've just used the rainbow color on script 164. So with that, I can execute, and you'll be able to see that it has changed. So I select the 3 lines and execute. And here we have our bar. And our bar is not well arranged. As you can see, it is not in ascending order. So we want to put it in ascending order. For you to put it in ascending order, you need to create some functions for order. we need to create some functions for order. So here, first of all, I'll create a function called sorted order, and here I'll say that order function order into counts. So I want these counts, the number of counties up there that I've created, the table that I've created should be sorted in ascending order. Then I come here and also I want to put the counts and corresponding categories to be also in a certain order. So it should be sorted. So here I'll create this object is called sorted underscore counts, then counts square bracket sorted order. This order that I've created in script 172. Then I come and also execute this. Then once I've sorted the order of counts, the order that was sorted, I come here and now sort the categories. This is the names of the counties also should be in some order. So here I'll say that the names sorted counts. So when I execute that, and once I've done that, I'll come here and also now put the sorted order in my plot. So here in my plot, still I'll use the bar plot, and I'll use the sorted order, that is script sorted counts that I've created in script 175, this one here. Then the main is the title of my graph. You'll see the title of my graph. Then X label counties, Y label number of TB HIV patients. Then again, the color, which is call equals to rainbow length sorted counts. Then names arrange equals to sorted category. So let me open it up so that we can see our plot and other windows. So when I execute this section, now our graph has been sorted in ascending order. You can see Wajir is the least, and then Nairobi County has the most. Now, what is missing is the numbers. So we want to know how many patients were from Wajir, TB patients from Kakamega, Bungoma, and here is our title, main title, TB HIV, then the Y label and the X label. So when I minimize this, now the next one is to add text. And text, we are adding it using the function, text. So the top part will create the bar graph that we've just visualized. Then the second part will be adding the text. So here will be text X equals to bar plot, sorted count, plot equals to false so that it doesn't plot this one. Then Y sorted counts, then label sorted counts, then position 1 to put it above the chart, slightly above inside the chart, then offset. So this is adjustment. And lastly, here we have the color. So I need to create here, open it a little bit so that we can visualize it. So when I execute that, you see now our bar plot has numbers. So you can see Wajir, we had 1051 patients, Kakamega 3,911, and Nairobi we had 20,878 patients. So that's how you add your text. You can also visualize. You can visualize in a pie chart. So that's how you create the bar graph. But pie charts also, you can use it to visualize using pie chart. And you can see here, say count. We create another object for sector, and I call it count2. Then it's a table format. Then pi equals to count2, main title, color, then rainbow, and the length of count2. So when I execute that, let me open. When I execute this section here, you'll see we have our pie chart. And when you go here, now this is our pie chart. But the problem with this pie chart, it doesn't have percentages. Now, how do we add percentages into pie chart? So here, to add percentages, we'll be forced to use ggplot2, that is grammar of graphic. So if you haven't loaded or installed ggplot2, you need to install. But if you had installed tidyverse, then there is no need of installing, loading or installing ggplot2, because tidyverse will come with ggplot2. So here I create account for gender. So every time you need to create the table for variable, especially for the nominal variables, the name. So I create for gender. Then I come here and now I want to change it to a data frame. So we are creating data frame for this. So here I'll come and execute it. So I've created a data frame because we are going to use this data frame gender df to create the pie chart. Once you've created, now you come ggplot gender underscore df x equals to blank, then y equals to count, then you fill with gender, then you come here geomba stats equals to identity width equals to 1 plus chord polar theta. So here we want to create a theta, then theme equals to void, then this will give us the title of our chart. So let's execute and I'll explain. So here now we've just created our pie chart. We've created our pie chart, but now our pie chart do not have any the percentages. Now percentages, we must create an object called percentages, and here this is how you create percentages. You say gender underscore df, then $ percentage, it will show us the percentage. Then you use the function scale. Use the function scale here, and you'll see scale now. Use the function scale, and scale will be percentage equals gender underscore df $ count, then sum gender underscore df $ count. So it will do the summation. So here it will pick male over total and female over total. With that, we execute this, and now when we want to add percentages, when you want to add percentages, we create labels. So 254 is what we'll use to add percentages. We'll say label equals to percentages. So when we execute the entire script, when you execute the entire script and we come to our bar chart, you see now female were 36%, whereas males, they were 64%. So that's how you add percentages. What about if you want to create a donut, that is a chart with a hole in the middle? This is the line, the script of code. The first one is for the data that you are using. So this is our data. So aesthetics, the same as the previous one without a hole. Then y equals to count, fill with gender. Statistic identity, the width is 1. Then what will make it to have a hole is now line 256, from line 256. So this will be still percentage. So here now we'll say scale equals to fill manual. Then the colors, those are customization of the colors. Then the adjustment of the legend. Then here we remove the title. We say that remove legend title, not the title, the legend title, because we don't need it. And now we adjust the text. So this is for the text. And here now is to also the text size that we are adjusting for our chart. So what will give it is the theme equals to void, and also this coordinate polar theta. So this theta is what will decide if we're going to have a hole. If we don't have this theta, it will just be a normal pie chart. But that theta makes it to be with a hole. So you see, that's our graph. So this is our donut graph. Then the inside one is the same as what we had visualized. Then the outer, there's this a hole here that we've created for the donut, and you can see the values still remain to be the same, 36% and 64%. So that's how you create the donut. Now, I want us to look at something that I did not mention earlier. It's called releveling. It is called releveling. So releveling helps us, especially when we have, we want to change the reference. We want to change the reference level. For example, if we execute, we look at the factor for gender, and you go to console, F will be our reference. F will be our reference level. But maybe we don't want F to be reference level, we want legend M to be reference level. How do you change the reference level in your variable? So first we start with the name of the variable that we want to change. So here it's gender. Then we say we use the function relevel. Then we df gender. Then our reference level, now we say that it is M. Remember, in the previous one, it was F, but we want to change it to M. So when I execute that, and I come and execute this line down here, script 288, if I execute it, you'll see that now the level has changed. The first one, the original one, it was, our reference level was a female, but now, once we've executed line 285, the level has changed to M. And we use this especially in regression analysis, because that's where you keep on changing the levels. That's when you keep on changing the levels of your data set. Lastly, I want us to look at the population pyramid. The population pyramid, the script is a little bit long. So we'll create a population pyramid using ggplot. And ggplot, we say that it has three key rules. That is, it must have the data. So this df is our data. Then aesthetics. Aesthetics is where you declare your x and also the y, as well as you fill color if you want to put the color. So here we say x equals to new age. Then we want to fill using gender. So these are our two variables, quantitative and qualitative. Then the geom bar, we are drawing the bars, and here data equals to subset df gender equal. When gender is exactly equals to M, then aesthetics will be y equals to negative the count. So when it is counting gender, it will want to count gender in respective to the age. Then position, we say dodge. Then transformation equals to count. Then this is just the width of the bar. Then colors is black. Then we come to, for female, we say again geom bar data, again gender is exactly equals to female. Then aesthetics equals to count. Now the difference between males and females is that the count under y for males is negative, that it will run from 0 to your or from 0 to the left hand, whereas for female it will run from 0 to your right side. So it's going to the negative. Then the same applies. Then we say here scale fill manual values equals to concatenate M. So for males we want it to be blue. For females we want the color of the bars to be green. Then lab title, this is the title of our pyramid, so population pyramid. Then the X equals to age and Y equals to count. But of importance is script 274, because now remember, for the label for age we had indicated to be negative. So if it was to write some values, it will write negative certain number, but we don't want it to be negative, and that's why we are saying scale underscore y underscore continuous label equals to ABS, and this means it's not negative. It should be whole number, whether it's running from 0 to our left hand side. Then code flip is for flipping our chart. So if we execute up to this point, you'll see that you need to tilt your head for you to see the chart. So, and we want to flip it so that you don't need to tilt your head, because we'll be struggling to read these values. So we want to flip count to be on the X axis and age to be on the Y axis. How do you do that? You add the function coordinate flip, and also we want the theme to be classic. So when you execute those lines of codes and you come to our chart here, you see now it has flipped. So that's how you visualize, and you can see there's this edge at the top where I've placed the cursor at the top. Then majority of our patients, they are within the reproductive age. Majority of the patients, they are within the reproductive age for both genders, and it reduces as they get older. Then also at some point the baby is also within the age of between age of 10 thereabout. We have fewer patients, but we have majority when they are young, when the babies are also very young, the infants, those under 5, you have quite a number. So that's what we've learned so far today. I'll share the script in tomorrow's class. So for those who will join our class, I'll give you the script. I'll send the script together so that you can keep on practicing and make it more better. So for you to learn R, keep on logging onto our YouTube channel. Click the notification button for you to receive a notification whenever we upload our video. Thank you for watching, and see you in the next class. Bye bye.